Okay, so my name's Jim Manning. I'm head of data and analytics at a place called Connected Homes. So also speaking, Josep, who's down here. Josep's my lead data engineer. We're in the process of building out a data platform, so I just wanted to talk a bit about Connected Homes, what that is, talk about what my team do, run through the products we have and the data that comes from those products, talk a bit about some of the use cases, and then Josep's going to do the clever technical stuff, and then we'll wrap up at the end. Does that work? No. So Connected Homes, it's a part of British Gas. Utilities have got a problem really because they're not very good at innovating. It's a heavily regulated industry, and innovation is hard in places than that. So British Gas wanted to do some innovative stuff in the Internet of Things space, and so they set up this organisation called Connected Homes. That's kind of what the offices look like. I don't know if any of you have ever been into a British Gas office, but most of them don't look like that. The British Gas headquarters in Staines is a kind of, it's a sea of desks with people like that who don't really talk to each other very much. Connected Homes is a much more kind of vibrant place. It was set up kind of to be like a startup. So there's about 150 of us now. We're completely separate from British Gas. We make our own choices in terms of the way we work. We make our own choices in terms of technology stack, etc. So it's a really fun place to work, and a really exciting place. So my area is these three things. So I kind of divide my world up into data science, analytics, and data engineering. So I'm really lucky. I've got a fantastic team. There's about 13 people in my group. A couple of really good data scientists. One of them an ex-NASA guy. I've got a bunch of analysts who are really good at kind of diving into data and sort of drawing out insight from that. And then the data engineering team, which Josep leads, who are kind of building all of the clever stuff that supports all of the other stuff. That's half of the data engineering team. The other half are on the other side of the picture. I took that on Tuesday. Are you familiar with kind of sprint planning sessions where everyone sort of holds up a number of fingers to kind of estimate stories, etc.? That's them all. I think they all estimated the same there. Although I did notice that Josep is the only one doing that. Now, I'm hoping it's because he's Spanish and it's some Spanish kind of thing, and he wasn't just being rude to me. But so in terms of products, Connected Homes have got three products at the moment. The first of those is called Hive. We launched that just over a year ago. We've got 100,000 customers. In fact, we celebrated the 100,000th customer very recently. Hive is a thing which allows you to control your central heating from your phone. So the way it works, you have this thing, which is a hub that plugs into your broadband router. That talks via Zigbee radio to this thing, which connects to your central heating boiler and does all the sort of nasty electricity stuff. And then you have a battery-operated thermostat, which sits on your wall wherever. They all talk via Zigbee radio. And then the Hive app talks to the platform and controls your heating. From a data perspective, every 2 minutes we get readings of the temperature in the house, the set temperature, so the temperature that someone has asked the heating system to go to. We get things like battery levels in the thermostat. We get whether the heating's on or off. We get a whole bunch of information about the quality of the radio signal between the three devices as well. So that's kind of interesting data. We do stuff like this with it. So this is where you all live. And what we're doing here is just animating UK temperatures in various different regions, and the little white dots that are coming on when people switch their heating on. So that's kind of interesting to us. It's interesting to an energy company. because if you can understand how people react to outside temperatures or weather, and make a decision to do something which is going to consume gas, obviously that's hugely interesting for a utility to know that kind of stuff. Other stuff that we've done with Hive data. So this is looking at how people set central heating schedules. So there's 4 colours on there. They correspond to the 4 main events that people tend to set. So this is a morning on and a morning off, and an evening on and an evening off. Time of day going across that way, and temperature going up the other axis. So that's kind of interesting because it helps us understand how do people set their heating schedule. It's interesting for an energy company to do that kind of stuff. You can look at the difference between the weekday and the weekend, and if I flip between those, you get the kind of amazing insight that people wake up later at the weekends. Who knew? Who knew? That has been very interesting for us actually, because understanding in terms of saving energy, setting your central heating a degree lower makes a massive difference. And so one of the things that we were able to do with this is to look very carefully at what our default settings were and how people reacted to those. And we made a bunch of changes to our default settings based off of this information. So that was an interesting thing to do with the data. So next product. This is something which is in trial at the moment. It hasn't launched commercially yet. It's called Connected Boiler. So inside of a central heating boiler, there are a whole range of sensors. So measuring temperatures at different points in the system, measuring pressures, measuring fan speed, measuring whether there's a flame or not, all of that kind of stuff. And in most boilers, that just goes to the circuit board, which is its kind of brain, and it just stops there. And maybe it gives you a fault code. We've developed with one of our suppliers this thing. This is a module which kind of clips into the boiler, and that takes all of those sensor readings and sends it back using the Hive infrastructure. So we've got a trial at the moment. There's 750 people on the trial at the moment. Been running a couple of months. It's generated 2.3 billion events. So there's kind of like more happens inside a boiler than you'd think it would. So what we're doing with that, well, as a product proposition, it's good because we know when a customer's boiler has broken, probably before they do. But we're also working on the data science to take those readings from the boilers and do stuff like this. This is some anomaly detection software that we wrote. So looking for anomalies. This boiler is not behaving in the way it used to. And what we plan to do over time, as we get more data and as we see more failures, is to use this kind of stuff as input features to some classifiers, and then our longer term plan is to be able to use that data to predict failure in advance. So again, for an energy company that has 7,000 guys who drive around in vans fixing boilers, understanding that one's going to break in a month's time or something is a really useful thing. Should we do questions at the end, or is that okay? So that's what we're doing with that. Third product is called Smart Energy Report. So Smart Energy Report it's based on data that we get from smart meters. That's a smart meter. We have 400,000 people at the moment who effectively give us a daily read of their consumption. 200,000 that give us a reading every half hour. We're working on developing a system which will allow us to get readings every 10 seconds and pushing that out to 5,000 people at the beginning of next year. We also have 3.8 million people who kind of self-enter monthly readings. So the stuff we do with that, we have the Smart Energy Report product. So this is it's a website which attempts to help people to understand their energy usage better. And we think by being kind of transparent with people about how they use energy, that kind of helps them. It helps us because it makes them So other stuff we do with that from a data science perspective. This is looking at clustering a bunch of those customers, 600,000 customers in the middle, and looking at data that they give us about their household, and then clustering that data to try and understand where big groups of our customers are. So that's another interesting thing that we do with that data. So I've been at Connected Homes for about 18 months now. When I arrived, there were 3 of us doing stuff with data. There's now kind of pushing almost to 15, and we kind of used a sort of ragbag of tools and techniques and databases, what have you, to do stuff with the data. And the data from each of those products very much kind of lived within the product. But because we've been able to do some useful stuff with the data, I think we've kind of proved that there's value in there. I was able to persuade the senior management team to make some investments. And so we've invested fairly heavily in people and in technology. And we're in the process of, or maybe Josep's in the process of building out a data platform. Cassandra in the middle of it, various other things floating around. We flirted with React for a while, but we kind of fell out of love with React. Chose Cassandra. I mean, in terms of the use case, I mean, most of our stuff is time series, so that's a good fit. We need to ingest large volumes of data, so that's a good fit. We were kind of really interested with the data stacks proposition as well, in terms of the support it would give us, and in building a greenfield thing which we hadn't done before, getting us up the learning curve. So that was all very useful. Okay, I'm going to go on now just to talk about a kind of very specific use case in the smart energy report world, and then after I've done that, I'll shut up and let Josep talk some proper technical stuff. So, non-intrusive load monitoring. That kind of sounds a bit weird. One of the things that we're really interested in doing with energy data is to break it down into categories. So non-intrusive load monitoring is all about being able to work out what an individual appliance in your house, how much energy that appliance uses, when the only thing you've got to go on is like the total house consumption. So you're kind of looking for patterns in that data and trying to extrapolate that back to an individual appliance. So we break stuff down into 6 categories. So heating, hot water, lighting, entertainment, appliances, and one other that I can't remember at the moment. And what I want to talk about is some work that we've done to take this half-hourly data, so every 30 minutes full house consumption, and work out what your fridge is doing. So fridges are exciting. It's only me that thinks that, okay. So the way it works is we take the 30-minute data. There's a bunch of filtering that happens on that data, and then we do some kind of interesting data sciencey stuff around the time series. And what you get as an output of that are things that look like this. And you find these are very characteristic pictures of how a fridge behaves. And from that data, we can apply some clustering to look at the density of those things. So we can color in here in the blue dots are representative of changes effectively in the signal, in the pattern that are down to the fridge. Once we have those, we can then run back through this stuff. So after the clustering, we identify those things. We then build a Markov model based on those inputs, and then we can run that Markov model over time and come up with a pretty good prediction of what a fridge uses, which is kind of cool to go from half-hourly data to actually say this is what your fridge uses. It's kind of cool for customers to, as a fridge gets older and it becomes less efficient, to start being able to see that degradation. And we think that's one of the things that can kind of really help our customers understand what things in their house are doing. So I'm going to leave it there and ask Josep to come up and talk about the data platform in some more detail. Do we have to swap this thing over?
Hi.
Do you want to have that?
It's up to you. This one is live. If you want to get it up.
I don't know how to do that. So, okay, yeah. So that's what we are building. We're just now starting to build this. So some of the things I'm going to explain is our initial findings. So it will be good if someone thinks that there's a better way of doing this stuff, and then we are very interested in knowing about this. As Jim said, there are a number of sources of information that we collect from homes. There is like temperatures and thermostat activations. There is even battery levels of the devices that are in the homes. And there's obviously information about the electricity and gas consumption. All that mainly we get in the form of queues. So all these devices, they communicate with an API at some point that collects this information and puts it in a queue. So what we are building is an engine that can collect stuff from queues and store it in a big database. We are planning to have 30 terabytes of data by 2015. This thing is just filling up right now, so we don't have 30 terabytes yet. So the way we have designed this is that in a way that it allows expansion. So we have a storage cluster and an analytics cluster, and we'll grow them as we need. So I'm going to talk about some use cases we are finding, and we're starting to find on how we collect this data, how we process it, and how we store it. So the way we have decided to collect the data is from queues. So we are starting to use Spark streaming to collect information from messages from queues and storing it into Cassandra. When we is it okay? Oh yeah, there's a difference. Then we have huge amounts of data, mainly coming from gas and electricity meters that need to be transformed to be consumed by the algorithms our data scientists have designed. So there's some transformation joins, things that are quite heavy that we need to do. And then we need to analyze this data, and I'm going to show how we are starting to productionize these algorithms, so that, because when data scientists design an algorithm like the fridge one, they do it with a small set of data, and they do it in a language that they know and they like, but then we have to make this thing work at a large scale. So there are some things that we have to do there. So for streaming, we have different sources of data. For example, for Hive Home, we think that we are going to have we have 100,000 customers right now, and in 2015, by the end of 2015, we think we'll have 200,000 at least. I think that's going to be more. So that's like 15,000 messages per second. We have the boilers. We're going to have 25,000 boilers installed next year, and that's like 2,500 messages per second. And then there is Live Energy. That's one of the projects that has to do with smart meters, where we install a device in people's homes, and this device collects every 10 seconds information about your electricity. And you have a mobile app where you can see your consumption in real time and other stuff about your electricity and gas consumption. So this is going to generate 8,500 messages per second. So what I'm going to show now is a very basic example of streaming with Spark. I mean, for some, maybe this is going to be very basic, but I find I think it's kind of cool. So we're using that as the basis of what we're doing. This example is using it's not using the Spark Cassandra connector, because we are using DataStax Enterprise 4.5, and this doesn't include Spark streaming. And this is using the basic data stacks Cassandra driver. And in this example, we have a connection to the database at the beginning, and then we consume a stream, which in this case it is a stream from the console of your computer, but this could be a Rabbit queue or a Kafka queue. We have tried with ZeroMQ also, but it really doesn't work because ZeroMQ in the version implemented by Spark Streaming is very old. This is because they use the Scala driver for ZeroMQ, which is in a very old version. So I would say that ZeroMQ really doesn't work with Spark Streaming at this moment. So this is very simple, but this is the basis of all the ingestion of data that we're going to use. I have here an example on how this thing works in the console. You just compile this project on a fat jar with SVT assembly. Then this is netcat. It's going to capture everything which is in the screen.